Hey Finxters! Today we will be discussing an interview question wherein we will be learning how to find the maximum product from a sub-array. Before we proceed further, there is something that you need to know, and that is what is a contiguous sub-array. Now let's say that you have the given array as shown on the screen. Now, a sub-array or a contiguous sub-array is nothing but a subset of the given array such that the indices of all the elements are adjacent to each other. That is, the indices are continuous. So 6, minus 3 and minus 10 is a sub-array in the given array. Similarly, minus 3, 10, minus 10 and 0 will also be another sub-array of this given array. However, there's a subtle difference between a sub-array and a subsequence. The indices of a subsequence may or may not be adjacent. That is, this subarray, that is 6, minus 3 and minus 10, is also a subsequence. However, 6, minus 10 and 2 is not a subarray, but it is a subsequence. This is because the condition for being a subsequence is that the elements have to be present in the array, but they do not have to be contiguous in all cases. That means 6 minus 10 and 2 is a subsequence of the given array. However, this is not a sub-array of the given array. Now, I hope that you have a clear understanding of what is a subarray. So let's dive into the given question and let's try to understand what the question asks us to do. So the problem statement states that you will be given an integer array nums and you have to find a contiguous non-empty subarray within the array that has the largest product, and then you have to return the product. It is guaranteed that the answer will fit in a 32-bit integer. Now, as I mentioned previously, that a subarray is a contiguous subsequence of the array. To better understand this question, let us go ahead and let's have a look at a few examples. So here's a list of examples that will help you to understand this question better. Let's have a look at the first example wherein the given array is 2, 3, minus 2 and 4. Now, if we try to find the subarray which leads to the largest product, then it will consist of the integers 2 and 3. That is, 2 into 3 leads to 6. Now, please note 2 and 4 will lead to 8, but that is not a subarray, that is a subsequence. Hence, the question asks you to find the subarray which leads to the largest product. Here, the largest product can be found by multiplying 2 and 3. Hence, 2 and 3 form the subarray in this case. And the largest product is 6, which you have to return as an output. Let's have a look at the second example. If you have a look here, then you have to consider minus 2, 0 and minus 1. You can even consider minus 2 and 0 or 0 and minus 1. Whatever may be the case, the product will always be 0 in each case. Hence, the output in this example or in this case will be 0. Let's move on to the third example. As you can see, in this given array, if you go ahead and consider the subarray which consists of the elements 6, minus 3 and minus 10, then the product becomes 180. Anything other than that, that is any subarray other than 6, minus 3 and minus 10 will lead to a product which is less than 180. Hence, the output in this case should be the largest product, which is 180. Similarly, in the fourth example, you'll find that the subarray which leads to the largest product is minus 2 and minus 40, which leads to the output as 80. Now, anything other than this, let's say you are considering the subarray minus 2 and minus 3, then that would lead to a product of 6, which is definitely less than 80. And the question asks you to return the product of the subarray which leads to the largest product. Hence, 80 is the largest product in this case, such that the subarray will be minus 2 and 40. Hence, you have to return 80 in this case. Let's have a look at the last example. Here, this array only consists of two elements, which are 10 and 20. Therefore, you simply have to go and multiply 10 and 20, which leads to the product 200. And that will be the output in this case. Now, I hope that this question makes sense. So let's dive into the solution and let's find out how we can solve this question. So as usual, let us try to understand the algorithm with the help of an example. Let's say that this is the given array which consists of the numbers 6, minus 3, minus 10, 0 and 2. Now, the idea of this approach is to keep a track of the maximum product in the given array by traversing it twice. That is, once you have to traverse from left to right, while you also have to travel from right to left in the second case. Now, to traverse the array from the right end until the left end, you can simply go ahead and reverse this given array and then store it in another array. So we will take the help of couple of other arrays wherein we will store the original array so that we can traverse from the left to right, and then we will create another array wherein we will store all the elements in the reverse order so that we can traverse from right to left. So let's try to visualize this. There we go. As you can see, we have the two arrays. The first array stores the elements from left to right, while the second array stores the elements from right to left. Now, in each case, you have to go ahead and calculate the result of the product of a particular element in the array and the element just prior to it. For example, let's say we are traversing through the array that keeps account of all the elements from left to right. In that case, in the first iteration, you have to go ahead and multiply -3 and 6 and then store the result of this multiplication in the current index. That is, in place of -3, this array will now store -18. Similarly, when you traverse from the right to left, you go ahead and multiply 2 and 0 and then store 0, which is the result of this multiplication, in the current index. So as you can see, we will be starting at the first index for both the arrays instead of starting at the index 0. Now you might be wondering, what if the array has only one element? In case the array has only one element, then you don't have to compute anything. You simply go ahead and return the only element that is present in the array. Hence, that is not a big issue. So let's focus on this, wherein we will be traversing the array and we will start from the first index instead of starting from the index 0. And then we will simply go ahead and multiply the value at each index with the value at the index prior to it. So in the first iteration, it will be the value at the first index into the value at the 0th index. So -3 into 6 is 18. Similarly, in the second array, it will be 0 into 2, which is 0. In the next iteration, we go ahead and then multiply the new value that we derived in the previous iteration with the value at the current index. And the current index now will be the second index. So that will be -10. So we multiply -10 and -18, which becomes 180. And we store 180 in the current index once we are done with the multiplication. Similarly, for the second array, you have to multiply -10 and 0, and the result of this multiplication will be 0, and we simply go ahead and store this at the current index of our second array. Then we move on to the next iteration, wherein we multiply 180 into 0. 180 was the value that we derived from the previous iteration, and 0 is the value at the current index of our first array. So this results to 0, and so we store 0 in the present or the current index of the first array. Similarly, for the second array, we go ahead and multiply 0, which was the result of the previous iteration, with -3, which is the value at the current index of the second array, and the result of this multiplication is 0. So we store 0 in the current index of the second array. Finally, we go ahead and multiply 0 and 2 for the first array, and we multiply 0 and 6 for the second array. And in both cases, we go ahead and store 0 at the respective indexes of both arrays, since in both the cases, the result of these multiplications is 0. So this is how the computation works, and we traverse the entire array starting from the first index until the last index in both the arrays. Once we are done with all these computations, we simply go ahead and find the maximum value among all the products that have been derived during each iteration. So as you can see that in the first array, the products are 6, -18, 180, 0 and 0. while the products in the second array are 2, 0, 0, 0, and 0. Now, among all these products, we go ahead and find out what is the maximum value among all the products. So that is 180. Hence, you simply go ahead and return 180 as an output. So that is how this algorithm will work. You simply have to go ahead and create couple of more arrays such that in the first array you will be traversing through all the numbers in the given array from left to right, and in the second array you will traverse through all the numbers in the given array from right to left. In order to create the second array, you simply have to go ahead and reverse the first array. So this is our first step. In the second step, we simply go ahead and begin our iteration such that we multiply the value at the current index with the value at the previous index. And we begin the iteration from the first index for both the arrays, and we go on until the end index for both the arrays. Once we get the result of the multiplication, we simply store the result within the current index in each array. Once this is done, you repeat this process once again until you reach the end of the iteration. That is, once you have traversed through all the elements of both the given arrays, and by the end of the iterations, you will have found the respective product, and then you simply need to go ahead and compare all the products derived in each iteration to compute the maximum value among them, and then return that maximum value as an output. To further understand this, let us go ahead and dive into the code, and let's break it down to understand this in a better way. So this is the piece of code that will help you to understand the algorithm that we discussed previously. Now, I have used a lot of print statements within this code in order to explain you how the code works. But don't worry, you do not have to use these print statements while you write the codes. Hence, this code is not as big as it looks as of now. Once we go ahead and delete the print statements, it will be a very compact code. However, as of now, for the purpose of understanding, let us keep the print statements and let's try to understand how this code is working. So we have our function max underscore product, which has the argument nums, and nums is the array that has been given to us. Now we simply go ahead and create a variable n, which stores the length of the given array nums. Now n will help us to iterate over each element in the array. So that is the purpose of n here. Then we go ahead and create couple of more arrays. As you can see, I have named them LTOR, that is left to right, and RTOL, that is from right to left. The first array stores all the elements from left to right. Hence, we simply store the array nums within LTOR, while the second array stores the elements of the array in reversed order. As I mentioned previously, in order to traverse the array elements from the right to left, you simply have to go ahead and reverse the array. So you can simply use negative slicing to reverse the given array. So once you have stored the elements as required within these arrays, you simply need to go ahead and begin your for loop. Now please note that we also have a condition wherein we can have only one element in the given array. In that case, you simply have to go ahead and return that element, as that will be the largest product in the given array. So you simply return that element itself. However, if there are more than one element, then we begin our for loop such that we iterate within the range starting from 1 until the length of the array, which is n. Now, if you remember, while explaining you in the diagram, I told you that we have to start from the first index. Hence, we are starting from the range of 1 until n. Otherwise, we could have simply iterated through the entire array. But our purpose is to begin from the index 1 instead of beginning at the index 0. Our next task was to compute or find the product of the element at the current index and the element that is at the index prior to the current index. So if the current index is I, then the index that is just prior to I will be I minus 1. Hence, for both the arrays, we simply go ahead and multiply the values at the current index, which is I, and the value which is at the previous index, which is I minus 1. And we do this for both the arrays, that is LTOR and RTOL. And once we are done with the computation, or once we are done with finding the product, we simply go ahead and store this result into the current index of each array. So that is what we have done here. We have simply found the product for both the arrays at the respective indexes and then stored the result in the current index in each iteration. Let's try to visualize this with the help of our diagram once again. So as you can see here, that in each iteration, we were first multiplying the value at the current index and the value that is prior to the current index. And once we got the result of the computation, we stored the product in the current index. So this is exactly what's happening in each iteration for both the arrays. And this is what this piece of code helps us to do. Once we are done with our loop, we simply go ahead and find the maximum value among all the products that have been calculated and stored within both the arrays. And how do we do that? We do that with the help of the max method in Python. So what does the max method help us to do? Max is a built-in method in Python which helps you to find the maximum value among all the values in a given iterable. So let's go ahead and let's have a look at a few examples to understand the usage of the max method. Let's say that we have couple of lists, li_1 and li_2. Now we want to find the maximum value among all these elements in this given array, that is in li_1. And we also want to find the maximum value that is present within this list li_2. So let's go ahead and print the maximum value in li_1 with the help of the max method. So we simply have to use the max method and pass li_1 as an argument to it. That will print the maximum value within li_1. Let's go ahead and execute this and find out what happens. And there we go. As you can see that among all the given values in list li_1, 200 is the largest value. Thus, 200 gets printed as an output. Similarly, if we go ahead and try to find the maximum value among all the elements in li_2, then we have to use the same syntax, and instead of passing li_1 within max function, we have to pass li_2 as an argument to the max function. Now let's go ahead and execute this. As expected, 100 has been returned as the maximum value among all the elements in li_2. Now, what if you want to find the maximum value among all the elements in li_1 as well as li_2? Now, the solution to this is very straightforward. You once go ahead and find the maximum value within li_1, which we found was 200, and then you go ahead and find the maximum value within li_2, which we found to be 100. Now, once you find the maximum value for both these lists, you simply go ahead and find the maximum value between these two values. I hope you get the point. Now, we simply go ahead and apply the max method once again upon these two values, and as we expect, the output should be 200 in this case. So let's go ahead and execute this to find out what happens. And as you can see, the output now is 200. Let's go ahead and let's make a few changes. Let's say that li_1 has another value 500. So now 500 should be the output. Let's see if that happens. And yes, that indeed happens. As you can see, 500 is the largest value returned to us. So this is exactly the concept that we will be using now. We simply go ahead and find the maximum value among the two arrays by simply finding the maximum value in the first array and the second array, and then applying the maximum function upon these values once again. So that will help us to yield the maximum value among both the given arrays. Now let's go ahead and let's use this example. This is the exact example that we used in our presentation previously. So let's go ahead and visualize this output with the help of the print statements that I have used here. So there we go. Now as you can see that this is the given array. Now we go ahead and create our arrays LTOR and RTOL. And as you can see, we have our arrays LTOR and RTOL. And as you can see, we are traversing LTOR from left to right, while we are traversing the array from right to left within RTOL. Now we begin our iteration. And we begin our iteration from the first index for both the arrays. So in the first iteration, the value at the first index for LTOR is -3, while the value at the first index for RTOL is 0. Now this should not have been I, this should have been LTOR at I-1. Just allow me a moment to make the changes. Okay, let's go ahead and execute this. Okay, there we go. So in the first iteration, the value at the first index, that is I at 1, will be -3 for LTOR, and for RTOL it will be 0. Now our next task was to multiply the value at the current index with the value at the index prior to the current index. So if the current index is 1 in the first iteration, then the value prior to the first index will be the index 0, and the value at the index 0 is 6 for LTOR. So as you can see, it is 6. Similarly, the value at the previous index, that is at the index 0 for RTOL, will be 2. Hence, we go ahead and multiply -3 and 6 for LTOR, and we multiply 0 and 2 for RTOL. And then our next step was to store the result of these multiplications within the current index in each array. So 6 into -3 is -18, and we store it in the current index, which is the first index. So we store -18 in the first iteration within LTOR. And we store 0 into 2, which will be 0, in the first index of RTOL in the first iteration. Now in the second iteration, the value of I is 2. So what is the value stored within the second index in LTOR? It's -10. Similarly, what is the value stored within RTOL at the second index? It is -10 once again. However, what is now the value at the previous index for LTOR? It is -18, since this is the value that we found previously and then stored it within the first index of LTOR. So now we find the multiplication of -18 and -10, which becomes 180, and we store the newly computed value once again within the current index, that is at the second index of LTOR. So LTOR at the second index will now store 180. Similarly, RTOL at the second index will store the result of the multiplication of -10 and 0, which is 0 at the second index. This is how we keep computing, and finally we reach the end of the iteration wherein the value of I is 4, and this is what LTOR and RTOL stores. Then we go ahead and find the maximum value between LTOR and RTOL, and that happens to be 180 in this case, and 180 is what we return as the output. So this is how this piece of code works. I hope that with the help of this breakdown of the given code, you have understood how to solve this question. Also, as you can see that you have to only traverse the given array once. Hence, the time complexity of this algorithm is n. That is, this algorithm has a linear time complexity. Let's go ahead and delete the unnecessary print statements now, and let's have a look at how the code looks once we delete these print statements. So we have removed all the unnecessary print statements, and as you can see that the code now looks a lot more compact and easy to visualize. But print statements helped us to understand the program flow. So I hope by now you have understood the importance of those print statements that we used previously. But this is the piece of code that will help you to deduce the final output. Now let's go ahead and let's execute this code upon the given test cases or the examples that we saw previously. That way we will be able to check whether this code works properly for us or not. And we will be super sure that yes, we can use this code in our interview. So let's go ahead and execute this code upon those test cases. So the test cases given to us are as follows. There we go. Now let's go ahead and execute this piece of code. So the expected output in the first case was 6 and 6 is what we got. Second case it was 0 and 0 is what we got. 180 in the third test case and 180 is what we got. In the fourth test case it should be 80 and 80 is what we got. Finally it should have been 200 and 200 is what we got as an output. Hence this code works perfectly fine and you can definitely use this in your interview if this question appears. Also, please note that this is an efficient code in terms of time complexity as it has a linear time complexity. Now, there are other ways of solving this question. One might argue that we are using couple of more arrays to solve this question. Isn't there a way to solve this question wherein we do not need to use an extra space? The answer to this is yes, we do have another way of solving this question without using extra space. However, this is not going to hamper your code a lot because this will help you to create a very simple solution. But when you go ahead and use the other methods, then they might not be as easy to grasp as this code. And it is quite possible that you may not come across with those ideas while you are appearing in your interview. So the idea is to solve the code in an efficient way as well as you should be able to solve it quickly. So this solution is a quick solution and it is also efficient in terms of time complexity. So you can definitely use this solution if this question appears in your interview. So that's it for this interview question. I hope you learned something from it. Please join me in the next lecture wherein we will be discussing another interview question. Thank you.